How are we doing today? Split remote sensing. And today we're going to talk about how we can use Darwin, which is the software we see in front of us, to plot spectroradiometer data. And then after that, we're going to plot spectroradiometer data using Python. So first, what is a spectroradiometer? This is a machine that can capture reflectance measurements at 3 nanometer increments along the electromagnetic spectrum. Our ASD spectroradiometer captures reflectance measurements up to 2,500 nanometers. And here we're in Darwin, which was developed specifically to interact with spectroradiometer data. So let's get some data into this. So File, Open Store Data Files, and we're going to go into H drive, thesis, spectro thesis data, and we're going to be plotting August 23rd. So I have this divided up, the raw data divided up into each site that we collected data. So we have sites 1 through 26. Now let's go ahead and open site 1, and we'll open up the 3 measurements that we took at site 26. Open that up, and it'll give us this option to open up a new multiple measurement plot. We'll go ahead and click that. All right, and we're going to zoom in. Because we sampled over a water body, the reflectance measurements are going to be pretty low. And we see that most of the reflectance is dominated by the noise around 2,000 and 2,500 wavelength. Okay. And we have the option, if we click and hold and then drag and release, we can zoom in on a particular area. All right, so we have our 3 measurements. This is great for initially visualizing our data, but the drawback is it can only interact with the raw files. After we collect this data, we go in, we clean it, and we average these 3 measurements into 1 measurement using Excel. And after we've done that, we no longer have the option to visualize the data in Darwin. And this is where Python comes in. So we're going to navigate to the IPython Jupyter Notebook. We already have it installed. And here we are. So we're going to work towards visualizing our data collected on our average data collected on August 23rd into 1 coherent plot. So I'm importing matplotlib.pyplot, and this is what we're going to use to actually plot the data. And then I'm going to import pandas as PD, and this is what we're using to manipulate the database. So we'll go ahead and run that, and we set our variable equal to reading the CSV file. So after we have averaged all the data sets, we save it in a CSV, and let's check out how that looks. Reflect 23, and we'll run that. And this is our database. So we have sites 1 through 26, and wavelengths starting at 345 up to 2,500. All right, so let's start working towards a plot in which we can visualize all 26 of these sites in 1 plot easily. So to do that, I'm going to start a figure instance. So fig23 is equal to plot.figure, and then we'll set the figure size here because it's going to have a lot of measurements in it. We're going to have a relatively large figure size, and that is going to be 14 by 7. All right, looks good there. Now let's just go to plt.plot and just throw in our entire data set. And then plt.show. Let's see. Oops, maybe we need here we go. All right. So we're going to have to work with this a little bit. First off, we're not really interested in anything too far beyond 1000 nanometers. So we can go ahead and restrict the x-axis and restrict the y-axis. So let's make that our next step. So then we'll go to plt.xlimit, and we'll set the x limit from 400 to, let's do 1000. And then we'll restrict plt.ylimit is equal from 0 to 10% reflectance. Plot that. That looks much better. All right, but we need a legend to be able to see or discern what's happening here. So that'll be our next thing. Right under plot, we're going to do plt.legend, and we're going to tell it reflect 23 is where you get the handles. We're going to lock in the center left, and you'll see why in a second. Because in order to get this outside of the initial plot instance, we're going to do bbox to anchor and set that equal to 1, 0.5. See what happens here. And there we go. We have a nice legend right outside of our plot, sites 1 through 26. All right. Now we can go ahead, add plt.xlabel, adding a label for our x-axis. The x-axis is going to be wavelength. Set the font size equal to 16. Go ahead and plot our y label. Set that equal to reflectance. Oops. Set the font size equal to 16. And then we'll also add a title here. plt.title. And we'll just name this Reflectance of August 23rd. And let's see what happens here. Oh, sorry, that's the R coming out of me, I think, or X label. And we'll also set the font size here, making this a little bit larger than for consistency. There we go. So this is a plot instance that worked. And we'll run that once more just so we can get rid of that initial plot. There we go. So we have sites 1 through 26, our average data set, in CSV format, which Darwin does not have the ability to interact with. So we have all of our sites 1 through 26 visualized in one plot. The next step is to just save the plot. So we'll do fig.23. Save fig, give it a name, reflectance 23.png. We'll run that, no errors. So now we go back home and we can see we have .png. There's our graph of our reflectance spectra, August 23rd, sites 1 through 26. Thanks for listening, guys, and we'll see you next time.